In this video, we are going to look at something called a limiting reagent. Reagent is also the same thing as a reactant, so if you see the word reagent or reactive or a reactant, they are the same thing. But rather, instead of jumping in straight to a chemistry problem, we're going to use a smoothie to kind of model the process that we're going to go through as far as working these problems out. The thinking is the same, and I think it may be useful if we use something that's more tangible, like actually making something in the kitchen, like a smoothie. But anyhow, let's go ahead and get started. So for this particular recipe that we've made, we're going to say that 10 ice cubes and 2 bananas mixed with 5 strawberries is going to be enough to make 2 smoothies. Now I know you probably want to put other stuff in your smoothie to make it better, like sugar or milk or whatever, but to keep it simple, this is going to be our particular smoothie that we are going to make. So let's go ahead and scroll down a little bit. So basically the first question that we're going to deal with in this particular example, it says, if I have 22 ice cubes and 3 bananas, what are the limiting and excess reactants? Well, a little bit of definitions first. Limiting basically means that it's what you have in shortest supply of, which basically means that you can't make more of a substance more than the limiting reactant that you have. Excess means that you have plenty of it, and basically for your reaction or making smoothies for this particular example, we aren't going to run out of. So the first thing that we need to do is to, in order to figure out what the limiting and excess reactants are, we need to go ahead and get a ratio from our recipe. So later on, our recipe is going to be the chemical reaction. So we know we're looking at ice cubes and we're looking at bananas. So if we look at this, we know that from our recipe that 10 ice cubes are going to give us, or will mix with 2 bananas, in order to make our 2 smoothies. So the ratio here is 10 ice cubes to 2 bananas. So I'm going to set up a ratio. So in a ratio, whatever unit I put on top must stay on top. It doesn't matter really what you put on top. Bananas could have gone on top. Ice cubes could have gone on bottom. But whatever's on top needs to stay on top. So I'm going to go ahead and put my ice cubes on top. So ice cubes go here. In the numerator on the top, and in the bottom I'm going to put bananas. So what I'm going to do after I set this up, I'm going to pick one of these. Now it doesn't really matter which one I pick, whether I pick the ice cubes or the bananas, because basically the way it's going to work out, once you find something that's limiting, you know the other thing or whatever ingredient you have has to be the excess. So maybe something that's analogous would be, let's say if I were to have 2 people in a room and I were to tell you that one's a boy and one's a girl, and if I were to go ahead and tell you that one of the people in the room is a boy, you automatically know that the other one is a girl. So it's just kind of like the definition. Once you have one, you know what the other is because there are only 2 examples. So limiting and excess. So let's go ahead and we're going to pick ice cubes. We could do bananas, but we're going to start with ice cubes. So I'm going to put 22 ice cubes up top. So now I'm going to put a variable in for my bananas. So what I want to know is how many bananas would I need to mix with evenly if I had 22 ice cubes. Well, I know that my ratio is 10 ice cubes to 2 bananas, but here I want to figure out how many ice cubes, or the 22 ice cubes need how many bananas. So in this case, I'm going to cross multiply. So I'm going to go ahead and take my 10 times my x, and I'm going to have 10x, and then I'm going to multiply my 2 times my 22, which is going to give me 44. So once I have this equation, I need to solve for my x. So I'm going to divide this side by 10, and then I'm going to divide this side by 10, and then I'm going to get x is equal to 4.4. Now if I look at this, my units, my x was bananas, so I know the units on my 4.4 is bananas. So now what this means is with 22 ice cubes, I need 4.4 bananas. So I'm going to say that I need 4.4 bananas to make this ratio work. Well, the next thing I have to do is look down here to see how many bananas I actually have. I've calculated I need 4.4 bananas, but I only have 3 bananas. So I need more than I actually have. So I know that bananas in this particular example is going to be the limiting ingredient or limiting reactant. Because what happens, if I look at this, I started out with 22 ice cubes. So really it doesn't matter if I had 1,000,000 ice cubes. I can only make what my bananas are going to allow me, because the bananas are going to are going to run out first, because I know it's the limiting reactant because I have 3 bananas here, or I have 3 bananas, but I need 4.4 bananas. So that is my limiting reactant. So by default, if I know that the banana is the limiting reactant, I know that the ice cubes are going to be in excess. Ice cubes are excess. So another maybe useful analogy to think of is if I've got a chain, and this chain, so we'll say a chain, any particular chain has 20 links in it. So a chain has 20 links. So let's say that each one of these chains, or each one of these links, each link can hold, we'll say, 100 pounds. So 100 pounds. Except for the last link. The last link can only hold, we'll say, 50 pounds. So even though my entire chain with 20 links, and each link can hold 100 pounds, except for the last link who can only hold 50, so that means once I put 51 pounds on this chain, it's going to break. So even though each one of these links can hold 100 and they're pretty strong, my last link can only hold 50 pounds, so my chain as a whole can be no stronger than 50 pounds. So I know it's kind of cliche, but you're only as strong as your weakest link. Well, this is where that cliche saying actually kind of comes from. But anyhow, in this example, like we said, we've calculated what the limiting and the excess reactants are by basically finding out what we need. We know we've calculated 4.4 bananas to need. I only have 3, so if I don't have what I need, I know that's going to be my limiting reactant. So let's scroll on down. We've got one more problem. So let's say this. So it says, how many smoothies can be made from 22 ice cubes and 3 bananas? Well, the first thing I want to do is I want to set up a ratio again. So I know from my recipe, I know that I have 10 ice cubes. So 10 ice cubes are mixed with 2 bananas. 2 bananas. Alright, so actually, let's back up just a second here. Okay, so let's back up here. So what I need to do, because I'm actually making smoothies, I need to do 2 bananas. I know that 2 bananas, when mixed together, will make 2 smoothies. And the reason why I am focusing on the bananas is because I know that is my limiting reactant. So once my bananas run out, that I know that my recipe is over, I can't make any more. So that's why we're looking at bananas compared to smoothies. So I'm going to keep my unit bananas on top, and then I'm going to keep my smoothies on bottom. So go up to my problem. How many smoothies can be made from 22 ice cubes and 3 bananas? Well, I'm going to put 3 bananas here, and I'm going to say X smoothies on bottom. So here I'm going to cross multiply, and I'm going to get 2X is equal to 2 times 3, which is my 6. So I divide this side by 2, divide this side by 2, and I get X is equal to 3 bananas. So I can only make, oh, sorry, not bananas. once again, got to pay attention to your units. So 3 smoothies. So I know that I can only make 3 smoothies from 3 bananas because my banana is my limiting reactant, and I know that from the previous example we did. Once again, even if I had, say, 100 ice cubes, I could still only make 3 smoothies with 100 ice cubes because I only have 3 bananas. So my 3 bananas are my limiting reactant. So the answer to this is 3 total whole smoothies.